Hello everybody, Happy New Year, and I'm back now. Today I want to do something slightly different. I want to do a bit of a series, and what I want to build is a remote control car using ESP in Rust. So I do want to focus on the software, but I do also want to actually use hardware. So what's the plan? The plan is something like this. I want to use actual hardware. I don't want to use a Wi-Fi access point and just really use internet stuff in the sense like that you control the car by posting JSON to a REST endpoint or something like that. I don't really want to do it. I think it doesn't really make sense. Maybe I'm gonna build a actual vehicle that can drive around. I'm not great at mechanical engineering and everything, so that might be a bit cringe, but I will try. And at least I want to have like all the components. I want to have a motor, a servo, whatever else comes to mind. So I do want to have the hardware. I want to design a remote control protocol so that we use our electronics and our software to control the car. Ideally, I also want to send telemetry back from the car to the controller so you can see in the controller what's going on in the car. I had I think it's a little bit getting a little bit much, but maybe I can use the ESP32 with the AMOLED screen on the controller, so I can build a sort of dashboard on that so that you can see what the car, that you kind of have a dashboard like you would have in a normal car, but then on your controller. And finally, maybe, I haven't really thought that one through much, but to integrate with some internet connectivity backend. And that's a little bit tricky, I think. I'm not sure if it can even be done, and we should definitely be have the possibility to go without internet for a while and then maybe later send the back-end events when there is an internet connection. Something like that. Yeah, the stack I had in mind. I start, of course, with ESP32 C3s. That's the easiest, and I'm pretty happy with them. On the controller side, I have some rotary encoders, some buttons, some whatever we need. It doesn't need to be elegant or particularly ergonomic. It's kind of the thought that counts, but you need to have something, right? As I said, I maybe use the screen for the dashboard, and I think I will be starting with ESP-NOW for the transport protocol. I think that's a pretty nice fit, and it is pretty easy to do. And on the vehicle side, at least a servo for steering, some kind of motor. I did steppers before. I have a bunch of those lying around, but they are kind of not the best to ride around with. I do have some drone motor here, maybe that one. That's like a brushless DC motor. I also have regular DC motors, also a possibility. I also have some gimbal motor, but that's a bit big, so I don't think I want to build something that's big enough to house that thing. And yeah, and that would mean that you can really precisely rotate the wheels of a car, and that's not really, I think, that useful. But maybe there is something nice, because like that gimbal motor does have a feedback function, so it actually registers all the movements it makes. And then you could send that back to the controller, for example. And then the controller, you could have like an odometer on your controller. Nobody really cares, but it would be cool. Yeah, and maybe an internet-based backend that we can store our telemetry on. Either so accepting the intermittent internet connection, that we have a way to store all the events and then send them when it's ready, or explore something like LoRa, which is kind of a low bandwidth protocol, but especially here in the Netherlands, like the coverage is pretty good, so you can basically use that for free. But yeah, I haven't really looked into that and figure out something nice as a backend stack. I mean, we could of course create a Actix or Exam backend on top of a Postgres database with SQLX, but that would be kind of boring. There are a million people who've done that. So I'll think about that one. I want to focus mostly on the code architecture, yeah, to make sure that we create something expandable. And this is more of a proof of concept than anything else, but maybe it's a nice way to get started, and maybe it's also yeah, good to challenge whatever Rust may or may not bring to the table. Pretty much, there are a bunch of RC control cars out there, the do-it-yourself versions, but they pretty much all use Arduino, and I wonder, yeah, what the exact impact is of switching to something like Rust. So that will be interesting. But yeah, getting the code nice, getting it organized, that it's easy to work on. Testing is also would be nice to improve that a little bit, because I haven't done anything of that lately. I think that's a weakness. That's on the no standard Rust, because yeah, the testing requires standard library, and I don't really have a good handle on it, on how to make that better. So finally, yeah, it's only a plan. I am not sure if it will work or if there are some huge obstacles, but we'll see how far we'll get. Life might also get in the way, things might happen, so who knows. If you have ideas or feedback, yeah, leave something in the comments. And as always, like, yeah, subscribe, just reach out for anything. It's really nice to hang out, to share ideas, or if you need help with something, I am there. So that's all for now. Let's do something. Okay, here we are. Let's get started. So I'll start as usual with cargo new, and let's call it Rusty car. And let's get into the Rusty car folder and start VS Code. I trust the authors. First of all, I would like to start with using workspaces. And workspaces is a feature in Rust where you can use several crates in the same repository. And because we need to have at least two, right? We need to have like the car and the controller that both have their own code base. I'm pretty sure we're also going to need a third one, that's the shared code that they both can utilize. And yeah, maybe more. So that works something like this. You have a workspace section there, and you have an array of members. That's empty for now, and there's also a historical thing that we need to say the resolver is 2. The default resolver, I guess default resolver 1, works slightly different, so we need to add that in here. I think that's all that needs to be here. And now we kind of have a super project. Let's remove that source one as well. So now we have an empty project. So if I go to the command line, I can do cargo new car, for example, and that will add an application package. So now it created a sub crate with its own cargo toml file and some boilerplate here, yeah, so basically that's how it works. I'm not going to do everything from scratch here. So what I am gonna do is I'm gonna remove the car folder, but I'm gonna leave it in the, as you can see, I didn't show you, but like it added it to the members as well, the car, so that's gonna remain here. I'm gonna copy one of the project we did before, the HTTP API, because it has already a configured network stack for ESP and ESP Wi-Fi. It has the embassy things all up and running, so I don't want to do it again. So I'll start here and then rip out what I don't need. So I'm gonna copy that -R to car. I removed car. Let's copy it here and rename it to car. In the car we need to clean up quite a bit. We're gonna remove the target at least, because that's the big one. In a workspaces project, so they all share a target folder, so that will be on the top level. So this one doesn't need to be here. We also can remove the cargo log file, because that one's also shared. That's actually quite helpful, because then you know that all the binary dependencies that are shared between sub-projects are synchronized, so they're the same. Let's see what it looks like in our IDE. So I think we have a VS Code here. Yeah, that's useful to keep. So we can move that to top level, or can we? I don't know. Like this. And then we need to have a look to the cargo tumble file. This is obviously not good, so we need to call that rusty car. Okay, well, this will get to that. There's a lot we can remove. You're definitely not gonna need Server JSON and Server for now. Pico server we're not gonna need. I think this one can go. What else? Small TCP. We're not gonna make actual TCP connection. We can remove that one. Let's see what this does. So, oh yeah, and this is the network stack, and this is the web stack. If you have questions about this one, really, please refer to the video I did. I'm not really. It's something like HTTP API that explains this code. Yeah, we're using a web and net dependency. We need neither, so we're just going to delete them. And let's see. And somehow it's not really building. Let's see what's wrong. What seems to be the problem? Let's see if we can build it from command line. So if we are in the top level, you can do cargo build package car. I mean rusty car. Let me get. Maybe I need to copy from car the cargo configuration to here. Might make a difference. Well, that looks a whole lot better. So let's see what if we edit here, if Rust Analyzer and VS Code will wake up. So there's obviously quite a lot of stuff we need to remove. Yeah, perfect. This I think should be fixed, but it might be a matter of maybe if I just touch this file, it might work. Let's focus on the other errors first. This one, we're not going to need it. Remove it. There was some stuff here as well. All these tasks, we don't need it. I'll leave one commented out. I'm not going to use Pico at all. I don't need the stack. I don't need DHCP. Basically up until here. Well, we obviously have a bunch of unused imports. This is okay, and this is okay. Yeah, and the other error with no standard also disappeared, so that's good. So now we have a kind of clean slate. Let's start by having a look at ESP-NOW. ESP-NOW, let me open the cargo file, is a feature of ESP Wi-Fi. I think you can also use it over Bluetooth, but we're going to use Wi-Fi. ESP-NOW. And that goes a little something like this. Let me see. So we have these, and then I can initialize ESP-NOW. So ESP-NOW instance, indeed, new, and then I need to that initialized this thing. Oh wait, I need to remove this one as well, because this will actually connect to access point, so that is something we don't want. Remove this. We need to have the init and that peripheral, the Wi-Fi that was just taken from the peripherals. That should be borrowed. Okay, now we have ESP-NOW thing. Let's assign it to a variable and see what it is. And it's a result. Okay, fair enough. And we unwrap it. Now what it is an ESP-NOW object. That's not very useful in itself. And what you need to do next, and you see it a lot in Rust in general, that you need to split it. And it has a function that returns, call it X for the moment, a tuple of 3 things. Let me get these out of the way. So there is a manager, there's a sender, and there's a third one you can't really read right now, and that's the receiver. So it's a tuple. So we can just deconstruct it here, and we call it ESP manager, ESP sender, ESP receiver. And they're not used, but now we have these 3 parts. And the split works like this because you want to separate the ownership as well. Because you might have different functions or tasks that have different responsibilities, and it's nice when they have separate ownership. Okay, so what does that look like? Let's see what we can do with ESP sender, for example. Sender, and we can do send, but we can also do send async. And as we have no thread and a single core controller, it is kind of nice to do as much async as possible. So let's create a task and create an async function, send something. And that takes an ESP sender, ESP-NOW sender, ESP-NOW sender. What's the problem? It needs a lifetime. Can we do it like this? I'm guessing not, but we'll see. Remove this one. And then we spawn it. We call send something and we give it the sender. Ready. I forgot the annotation task for embassy. So that actually changes the whole function. What's wrong? Yeah, it wants this to be static, I figured. Let's see if that works. ESP sender. That does the trick. So now we have a sender in the async function context. So now we can use the async function. If I would try to do it here, so ESP sender, and I would call a send async here, then it will, well, I mean, you'll have to believe me now, but you can only call async functions in an async context, and this is not one. This is not an async context. It needs to be an async function, and a task is just that. So when we are here, let's do a little loop. As usual, we send something, send async. We need to give it an address, which is 6 bytes. And that identifies different ESP32s. I'm not 100% sure how it works, but there is a special address that we're going to use all the time, and that's the broadcast address. And the broadcast address will just arrive to everybody who hears. So it makes life easier, and as we have only 2 devices in this case, it's all we need. So that and some data. So let's say hello rusty car, and we do it to 2 bytes as bytes. Okay, let's see what's wrong. And we need to await that, of course. This probably needs to be a borrow. And it should have been mutable. Okay, and we need to unwrap it as well to silence the warning. So now it sends something, and experience teaches that we also need to pause a little bit. So we say after seconds 1 and await. So now it will send hello rusty car every second, which is something, right? Let's see if it works. So let's do cargo ESP flash, and we specify the package rusty car. So I have 2 ESP32s plugged in, one here, the USB on the port 14130, and there's another one on this one, which is a slightly different model, but it's still the same chipset. So let's use this one. it doesn't really matter. And we are going to flash it here and let this do its thing. So right now it's not gonna do anything, it doesn't even print anything, so it will be just silence, and there is nobody listening. So it's not like TCP that you notice when you're not reaching anybody. It is just you send out a packet of information to the ether, and either somebody reads it or somebody doesn't. And if you need any logic about acknowledging it or knowing who received it or whatever, you'll have to do it yourself, which is fine for what we are doing. So this worked. Oh, I didn't monitor it, but oh, that's gonna flash again. Yeah. So yeah, it's okay to do that ourselves. There's one limitation that might be a problem, but not really in the near future, is that there is a limit to how big packages can be in ESP-NOW. I think it's 255 bytes. So if you need more somehow, you need to send multiple packages and make sure that the receiver knows how to glue them all together again. So, but we'll see if that will be a problem. I kind of doubt it. So now it's started and it's just sitting here doing nothing. So let's leave it here, and let's create a controller, because now we had the car, and let's create. Let's copy the car and we call it controller. Now we have controller. We also need to add it to our top level. We need to update the name, so we call this Rusty controller. And for the rest, we can, at least for the time being, get away with making it all the same. One of the advantages of using workspace is that I could put all of these shared things into the top level cargo tunnel that has nothing now. So you can basically delegate the dependency, so you have to only update it in one place. Right now I'm not going to do it yet. One reason is that I might want to use a different controller for the controller versus for the car. So I think it will make life more complicated, but it has an extra burden of maintenance if you want to do that. So let's update our controller. Oh no, let's not update controller. I think the controller is sending something now. Yeah, we did it basically the wrong way around. Shall we fix that now? Yeah, let's fix that now. So this one we're gonna stop now. Well, we don't stop, but we disconnect. And the car shouldn't be sending, the car should be receiving for the time being. So we had this function here, send something, and we call that receive now. And we take a receiver, and that's ESP-NOW receiver, and that does receiver receive async and await, and let message. Let's see what it is. It is a received data, and that has a bunch of fields. Well, not that many actually. So you have the data, which is the array, and we have an accessor to get a slice of that, depending on what in there with the length. And we have some info, which, for example, shows who sent it in terms of address, where it was sent. Neither is interesting in our current situation, because we just want to we have just two controllers, so that doesn't matter. We just want the data, so let's decode the message, and we do a from UTF-8, and we put in there the message.getData. And then I think we need to unwrap that. And now we have a string pointer. And let's print that to the output. Receive message. Message. And we don't need to pause. It will wait until something happens. Let's print something to make sure that we know that we're actually looping. See if we're started. And then we need to, of course, call this receive, and we need to give the receiver here. I'll clean up later. This should work. So let's run the code for the car again and see where we end up. And then after that, we should be able to run the controller. So ESP flash. Did I use release? I'm not sure. I should, but I need to monitor, and we need to do package rusty controller, or was it just controller? I'm not sure. So now I pick the other one, this one. I don't want you to remember it, and let's see what that does. Oh, it's funny. Look, this is the one we were just flashing before, and it started to receive messages again already. I guess that was an older version I had flashed onto it. But let's see what happens now. Still uploading. Look, now it starts saying hello rusty car. And if I unplug the rusty car, no, which one is it? I'm not sure if I'm unplugging the right one now. Let's see. Yeah, you can't really see it because it I cleared it now. Now I plug it in again. You can see it here. And then it starts saying hello rusty car. This one is the sending one, right? And then I unplug it, it stops. But what's nice is, for example, that it really starts quickly, right? I'm here, I plug it in, click, and it starts running. It really starts instantly. So that's kind of nice that you don't need a lot of... if you would be connecting to a Wi-Fi access point and that sort of stuff, it will take way longer. So I think it's a nice place to call it. Next time I'll continue with other stuff. Nice, thank you. See you around. Please leave a like if you have a moment, and comments are welcome, and see you around. Bye.